Alright class, this is 9.5 day 1, which is sum and difference formulas. So these are the formulas. You will be given these. The only thing you have to really note about these formulas is when you expand cosine, notice how that goes from plus minus to minus plus, and also with tangent down here, same thing. They're highlighted in blue. That means you use the opposite sign of what you had to begin with. So to do these problems, you have to figure out the good angles. And when I say the good angles, I'm talking about the angles that we're used to seeing on the unit circle. And we have to figure out a way to get 285 using our good angles. A little hint, if I see a 5, I usually think I'm going to have a 45 in there. So if I think to myself, what is 285 minus 45? That'd be 240. So I could rewrite this as 240 degrees plus 45 degrees. Okay? Then, if I look at my formula up here, it's saying, well, if I have a sine of alpha plus beta, and alpha and beta are just variables for angles. So right now my alpha is 240, my 45 is beta. Then I can write it like this: sine of 240 cosine 45 plus, because it's the same one and I have a plus down here, cosine of 240 sine of 45. So that's what I'm going to write right now. So this is equal to sine of 240 cosine of 45. Then it's the same sign that I had, which is that, and then it's cosine of 240 sine of 45. And like I said, you'd be given the formula, so really you just have to figure out, first thing you have to figure out is how to split the angle into two added together. The next thing you have to do is evaluate this. 240 is a 60-degree reference. Sine is root 3 over 2, but it's in quadrant 3, so it's negative. And then 45 is always our root 2 over 2's, plus cosine of 240 is 1/2, but it's in the quadrant 3, so it's negative, and this is root 2 over 2. So my final answer is, I multiply these, I get a negative root 6, multiply those, minus root 2, and then the denominator here is a 4, the denominator here is a 4, so I can make it a common denominator of 4. Now, you do not do anything with those radicals. You do not say minus root 6 minus root 2. You can't subtract those. So, alright, let's take a look at tangent of 15. Again, I have to figure out a way to get 15. You always want to try to use 45 when there's a 5. So, I could have done 45 minus 30. I could do 60 minus 45. It doesn't matter. That's the great thing about this. As long as it adds up to the correct angle, you're good. So now I'm going to use my formula for tangent. So since I'm using a minus sign, the top one's also going to be a minus, but the bottom one will be a plus. So it's tangent of 45 minus tangent of 30 over 1 plus tangent of 45 tangent of 30. Okay, so now we just plug our values in. Tangent of 45 is 1, minus tangent of 30 is 1 over root 3, over tangent 1 plus, whoa, something's happening here. Alright, hold on one sec. Oh, we're back. 1 plus, when you multiply 1 times 1 over root 3, you get this. So this is kind of like the final answer if you don't rationalize it, but you can make it look really nice by multiplying the top and the bottom by root 3 to this whole thing. So if I distribute a root 3 to there, I get root 3 minus, these will cancel, you're left with a 1. Root 3 times 1 is root 3. Root 3 times 1 over root 3 is 1. So that would be more simplified. Okay? Now with radians, you want to look for fractions that reduce. Okay, so I have 7 pi over 12. So to get 7, you can use 1 and 6, 2 and 5. But here's the question. 1 does not reduce with 12. 5 does not reduce with 12. So what's another option? Well, 3 and 4. 3/12 and 4/12 both reduce down to unit circle angles. So I'm going to say that I want to do the cosine of 4 pi over 12 and plus 3 pi over 12, because that is 7 pi over 12. Which means that it's going to be the cosine of pi over 3 plus pi over 4. And those are both reference angles in quadrant 1. So now I go up to my formula, and look, in cosine is this formula here. Notice how cosine has the opposite sign that we start with. So we're starting with a plus. So it's going to become cosine of pi over 3, cosine of pi over 4. And then because this was a plus, I'm using a minus. Sine of pi over 3, sine of pi over 4. So pi over 3 is 60. The cosine is 1/2. The cosine of pi over 4, which is 45, is root 2 over 2. Minus the sine is root 3 over 2. And the sine of that is root 2 over 2. So just like before, notice how if you multiply these bottoms together, you get a 4 and a 4. So we have a common denominator of 4. The top is root 2 minus root 6. And we're done. Alright, the last one of these kind, we have a cosecant, so to do this, find the sine one, then flip the answer. So pretend this is the sine. So we're going to find sine of pi over 12. First we have to figure out how to get pi over 12. Well, the good news is we can use the same two angles we used in the last one. We used 4 plus 3 is 7, but we could do 4 minus 3. So I'm going to do sine of 4 pi over 12 minus 3 pi over 12, just to make sure that looks right. So that reduces to sine of pi over 3 minus pi over 4. So now I'm going to go back to the sine equation at the top and expand this out. So I'll do this so you know where we are. So this is equal to the sine of pi over 3, the cosine of pi over 4, and then since it's the sine one, it's the same sign, so we minus sine cosine of pi over 3 sine of pi over 4. Okay, now we just simplify. So I get at pi over 3, we just did these. Sine of pi over 3 is root 3 over 2. And then we get root 2 over 2. Minus cosine of pi over 3 is 1/2. And again, we have another root 2 over 2. So this answer becomes root 6 minus root 2 over the common denominator of 4. However, I want cosecant of pi over 12. Cosecant of pi over 12 will be 4 over root 6 minus root 2 because we have to flip sign. Okay? So that's the only thing you have to add to it when you have a trig function that's one of the reciprocal ones. Alright, so now the last thing we're doing today is doing these without unit circle angles. We're just going to be dealing with triangles. I actually kind of think these are easier sometimes. So first thing you have to do is draw the triangle in the correct quadrants. So we have to find cosine of alpha plus beta. Actually, I'm going to just write that out, the formula that'll turn into. This turns into this. Okay, which is just the formula up above. So sine of alpha, or alpha's in quadrant 1, and I know that because this is between 0 and 90. This is between 90 and 180, so this is Q2. So if I draw these two triangles, here's Q1, I'll draw a triangle. Sine is opposite over hypotenuse, or y over r. There's my theta. I'm not going to show it here. You can do Pythagorean theorem, but this is just 5, 12, 13. All of them are positive because we're in quadrant 1. Oh, actually, you know what I should write here is alpha, because that's the angle we're using. So this is the alpha triangle. And then we are going to go into Q2. Q2 will draw a triangle this way. Tangent is negative 1/2, so that means the tangent is y over x. Double check where the negative goes. It goes with the x because we're in Q2. I'm going to put the beta there just so I know that's my reference. And then, even though technically beta is that angle. Then we have to do Pythagorean theorem. 4 plus 1 is 5, so this is root 5. So we have our two triangles, and we have our equation. So literally over here, I just start subbing in. You do not put them in just for alpha, though. You use the whole triangle to figure out what is the cosine of this triangle. So for example, the cosine of the alpha triangle would be adjacent over hypotenuse. So this becomes 12 over 13. The cosine of the beta triangle, negative 2 over root 5. Minus the sine of the alpha triangle, hopefully you get this right, that was given to you in the problem, 5 over 13. And then the sine of the beta triangle is 1 over root 5. Notice how I do not have any sines or cosines left over. That's one of the major mistakes I see, is people just put these numbers in for the alpha and the beta. Alright, now we can just simplify this. This is negative 24 over 13 root 5 minus 5 over 13 root 5. So since they have the common denominator, you can subtract those. You get negative 29 over 13 root 5. Alright, so that is that one. Let's do one more. We're going to do tangent with these two triangles. Again, I'm going to quickly note that this is in Q1 from 0 to 90. This is from 180 to 270, so that's Q3. And tangent, I'm going to rewrite tangent out here, so this formula turns into tangent of alpha minus tangent of beta over 1 plus tangent of alpha, tangent of beta. Because remember, this is the same sign that you have in the thing you want to expand. This is the opposite. Alright, let's draw our triangles. Q1 triangle. This is alpha. Cosine is 5 over 7, so that's adjacent over hypotenuse. If you do the math here, 49 minus 25 is 24, so this will be the square root of 24. For this triangle over here, we're in Q3, so that goes this way. And this is beta. It says that the sine is negative 3/5, so this would be 3, this would be 5, the sine is negative. The cosine will also be negative. This is a 3, 4, 5 triangle, so you should get that as your second triangle. Once you have the triangles, you're just subbing the values in. So tangent of alpha is root 24 over 5. Minus tangent of beta is 3 over 4, because of the negatives cancel. All over 1 plus tangent of alpha, which is root 24. We already know these, actually. I don't need to keep going back to the triangle. And then 3/4. Okay, so for right now, we're just going to stop there because of the time, and you can just say that's what it is. You could do some simplification, get a common denominator, flip it, multiply, a lot of work there. But right now, honestly, you just need to know how to get this fraction. Expand it, you get the triangles, you plug the numbers in for the whole thing, and you're done. So, alright, well, hopefully you guys are good with this, and I will see you next time.